All right, in this video, you are going to learn how to multiply your radicals together. I'm going to give you 3 examples to go over so that you can see different types of problems. In this case here, we've got root 5 outside of a binomial with 2 irrational roots inside of it. So what we need to do here, you can go about it a couple different ways. Well, the way I'm going to teach it is just distributive property. So we're going to say root 5 times root 3. Now, if they both have radicals around them, but they're not the same value, you just multiply those two numbers together and keep the radical around it. So 5 times 3 is 15. And then 5 times 75 is going to be, well, it's a negative root 75. So positive times a negative is going to give me a negative root 375. Now, my next step, I'm looking at what I have here. And 15 can't be simplified at all. We can't split 15 up into 2 values, one of which is a perfect square root. But we sure can do that with this one here. Root 375 is no different than taking root times another root. And those two numbers, I want one of these to be a perfect square. So 375, 25 seems like it would go inside of that, no problem. Well, 25 times 15 is what gives me 375. So now what I have is root 15 minus root 25 times root 15. Well, look at that number right there. Square root of 25. You would never leave that as a square root of 25. You would simplify that to 5 because 5 times 5 makes 25. So now this is 5 root 15. It's a negative, remember. And then we're going to bring this one down. So now we're no longer multiplying, now we're adding and subtracting these values together. Now, a lot of times kids will get to this last and final step, and they'll treat this as if it's 0 minus 5. Because these are both root 15, we call them like radicals. No different than like terms, right? It'd be like a 1x minus a 5x. The reason I can put x's there to represent those is because notice x's are the same. Root 15s are the same. So because the index, the number here and here in the crevice is the same, as well as the radicand, those are the same, we call those like radicals. So when you have like radicals, you're allowed to add or subtract them together. So what would 1 minus 5 leave me with? That would be a negative 4, but because these were the same, we need to have that attached right there like that. So negative 4 root 15 would be your final answer for this problem here. Let's go and take a peek at a different one. Check that one out. This one's a little bit different because now we've got a binomial, 2 separate terms being squared. When I tell kids when I have 2 or more terms in parentheses being squared, you should just write that down twice, or if we're cubing it, you would write it down 3 times. And we're just going to set it up being multiplied by itself. So we've got 2 root 5 minus 4 times 2 root 5 minus 4. Now, however you were taught, maybe you were taught the FOIL method, the distributive property. Sometimes you make boxes and you can split it up that way. However you were taught to multiply your binomials together, go with what you're comfortable with. I'm a huge fan of just distributing. So we're going to distribute this term to both of those terms here. We're going to distribute negative 4 to both terms over here. And if I multiply all 4 of those lines together, I'm going to get what I need. So 2 root 5 times 2 root 5. Well, what's 2 times 2? That makes 4. But a root 5 times a root 5 times root 5, this could be represented as root 5 squared. And what do we know about an exponent of 2 and a square root? Those are inverses of each other, so they cancel each other out, leaving you with just 5. So 2 times 2 makes 4. Root 5 times root 5 is going to leave me with just a 5. So I got 4 times 5 for the first multiplication that I've done. And that's this line right here. Now I got to do the second line, which is this line. 2 root 5 times negative 4. Well, that's going to come out as a negative. 2 times negative 4 makes negative 8. Root 5 stays attached. Negative 4 is the next thing we need to multiply. We need to do the inside term. So negative 4 times 2 root 5. Well, a negative 4 times a 2 gives me a negative 8. And then root 5 stays attached. And last but not least, we got a -4 times a -4. Make sure you're careful. Negatives times negatives make, you guessed it, positives. 4 times 4 is 16. So I've got all this information here. 4 times 5 is really just 20. So I'm going to erase that and just change it to the value of 20. And now I've got some like terms and some like radicals. Here's my like terms. A constant can combine with another constant through addition and subtraction. So 20 plus 16, that's going to give me 36. And then I've got -8 root 5 minus 8 root 5, which is going to give me negative 16 root 5. Again, remember, treat this like -8x minus 8x. You would get -16x. So this part doesn't change. It stays the same. Your radical will stay the same, but then your coefficients, essentially, they're going to add together or combine together and get -16 here. So what I got now is 36 minus 16 root 5, which would be my final answer for this problem. Let's take a peek at another one. Now on this last problem, the only difference is we're dealing with cube roots here, right? So one thing about cube roots is we're allowed to have a negative radicand. We can have a negative value inside there because a negative times a negative times a negative 3 times can come out as a negative. So that's allowed. It's not allowed with square roots, but it sure is allowed with cube roots. So what we're going to do is we're going to multiply this. We're going to multiply that right here. A -4 times a 2, because these are the same. They're going to stay cube root. -4 times 2 is -8. Now, what's the cube root of -8? We'll get that in a second and simplify. But now let's also multiply -4 times cube root 16. -4 and a 16, right? That's going to give me minus cube root. Minus is right here. -4 times 16, that's negative 64. Well, that's a good number. I like that number because I know that the cube root of -64, that's going to be a -4. -4 times -4 times -4 makes -64. 2 times 2 times 2, or -2 times -2 times -2 is what makes 8. Multiply that 3 times. Okay, so we got this, and then that gets brought down like that. -2 minus -4. Well, subtracting a negative is really adding, so we're taking -2 plus 4. Our final answer here is just going to be a 2. Okay, so cube root's a little bit different. You just got to pay attention to the negative values. Make sure you're taking negatives times positives and giving them as negative results. Okay, but basically all we're doing here is the distributive property and using our radical properties that we know to make sure we're getting the right results at the end. Hopefully this makes sense. Study hard and good luck on your upcoming test.